Winter weather comes over the U.S. in December, with the polar vortex core moving into North America for the extended range. Winter 2024-2025 is about to begin, meteorologically, in a very dynamic way. A strong train of pressure waves is building across North America. But by the start of December, a low-level polar vortex core will move over Hudson Bay and the northeastern U.S., bringing a northerly flow and colder air across the United States. This article was updated on the 25th of November, 2024, with the latest medium-range maps and extended-range data. The movement of the lower polar vortex is always important, and one of its cores is on the move into North America. It will create a special condition called a cross-polar flow. That occurs because a low-pressure area spins counter-clockwise, pulling down cold air from across the polar regions and into the United States. Atmospheric waves. The current weather pattern across the North Pacific and North America is very dynamic. In the image below, you can see the latest pressure anomalies that formed in a wave-like pattern of highs and lows. Such pressure waves are an attempt of the atmosphere to balance out the temperature difference between the cold poles and the warm tropics. These pairs of pressure systems are also known as Rossby waves. You can see an example of Rossby waves in the image below by NOAA. As you can see, the current pattern above is quite a textbook example of a Rossby wave train from the Pacific into North America. The purple line connecting these pressure systems is called the jet stream. This is a rapid flow of air at around 9 to 14 kilometers, 6 to 9 miles, above sea level. It drives and interacts with the pressure systems, thus helping to directly influence our daily weather. That is why any changes in the jet stream are very important to monitor. The term jet stream is behind extreme events, from cold spells and flooding to heat waves and droughts. It is a fast, narrow current of air flowing from west to east that surrounds the globe. The image below shows an example of the global jet stream in a NASA visualization. This is even better seen in the high-resolution video animation below, which shows the flow and movement of the jet stream across North America. It was developed by the NASA Goddard Space Flight Center Scientific Visualization Studio. This affects the temperature anomalies across North America, seen in the image below. Just like with pressure anomalies, you can see the temperature waves of warm and cold areas. Currently, a warm anomaly is present over the eastern United States and northern Canada, but a cold anomaly wave is starting to descend into the U.S. on the cross-polar flow. These temperature patterns directly correspond to the high and low pressure systems and the jet stream that connects them. The strongest cold is usually found when the jet stream is wavy, and these pressure waves are strong, and the low pressure area of the wave is directly over the United States. But there is a reason why we are learning about pressure waves and the jet stream. In the coming days or weeks, a large pressure anomaly is forecast to settle over Hudson Bay. An extension of the polar vortex itself, it will bring more cold in the last days of November and into December. A cross-polar flow starts. One of the important factors in every cold weather season is the polar vortex. Now, this is a rather broad term, but in most cases, it is used to describe the whole weather circulation from the lower to the higher levels of the atmosphere. For this reason, we tend to separate the entire polar vortex into an upper, stratospheric, and a lower, tropospheric, part. They both play their role differently, so we monitor them separately. But it is also very important how they are connected. Image below by NOAA Climate. As you can see, the lower polar vortex is larger and more disrupted because it has to interact with complex terrain and mountains across the Earth's surface, and strong pressure systems. This means that the lower polar vortex is much more dynamic and can be broken apart, and its cores are more free to move around. Below is the forecast image of the polar vortex in the lower stratosphere at the 50 MB pressure level, 20 kilometers, 12.5 miles. You can nicely see how the polar vortex is elongated in shape, pressed from both the Pacific and the North Atlantic side. That elongates the polar vortex, pushing its core into an oval shape, and extending it into North America. Below is the low-level forecast for the final day of November, which shows a broad low-pressure area over the United States and eastern Canada. Because a low-pressure system spins counter-clockwise, this will create an active cold air transport line directly from the polar regions, called the cross-polar flow. Images by weathermodels.com. Looking at the whole lower half of the atmosphere on December 1st, you can see how the large low-pressure anomaly over North America shows a direct core connection upwards into the main polar vortex above. The second core of the polar vortex is connecting down over Siberia. Image by weatherischool.com. A polar vortex core over Canada and the northern United States pushes the jet stream towards the south. You can see it in the graphic below, showing the jet stream forecast for the end of the month. With the jet stream moving south, it means colder air is following behind, and it also means that smaller low-pressure systems will move directly under it. To put that into perspective, you can see the temperature forecast image below. It shows the surface temperature anomaly for next Thursday, when the cross-polar is expected to reach down into the southern United States before turning east. Negative values show colder than normal temperatures around Thanksgiving across a large part of the northern, central, and eastern U.S. Looking at the first day of December, the cold air anomaly is forecast to spread further east, reaching beyond the east coast of the United States. The main source region of the cold air is still in the northern United States and southern Canada, driven by the strong northern winds of a strong cross-polar flow. The surface temperature forecast for the first days of December below shows near or below freezing temperatures over a large part of the United States, bringing proper seasonal winter weather to much of the lower 48 on the first days of meteorological winter. The only exception is forecast over the southern and southeastern U.S. Looking at the total snowfall forecast until early December, you can see the whole of southern Canada and the northern half of the United States experiencing snowfall. This is not snow on the ground but the snowfall amount based on total precipitation. So we now know that meteorological winter is about to start with proper seasonal weather. But how long will it last? Cold weather continues. Looking into the first week of December, you can still see the deep low-pressure anomaly sitting over the northeastern United States. The overall circular low-pressure zone is still over Hudson Bay, connected to the polar vortex. Below is the surface temperature anomaly forecast for the first week of December. You can see the main cold air source in the northern United States and southwestern Canada. From there, the northerly flow brings the cold air and the negative anomalies into the Midwest, central and eastern United States. Looking at the temperature anomalies at the 850 MB level, 1500 m, 5,000 feet, we can understand the overall air mass higher above the surface level. You can see that most of the eastern half of the United States is forecast to be under a colder air mass in this period. It indicates continued cold air transport from the north. Below is again the total snowfall, but this time reaching until December 6. It doesn't show snow on the ground, but the total snowfall amount based on precipitation. You can see decent snowfall amounts across much of the northern United States, the Midwest, northeastern U.S., and eastern Canada. Some scenarios also push snowfall into the south-central plains and the lower Ohio River Valley. That will be easier to determine once these events reach the more accurate short range. Looking deeper into December with the normal forecasting tools is a bit of a stretch. But what we can do is look at the early trends and large-scale anomalies and signals. So the following forecasts should be taken for what they are, just the latest forecast trends and ideas. The first winter month of December. Looking at the extended range forecast trend for mid-December, you can see continued low-pressure areas over eastern Canada and the northeastern U.S. This still hints at a likely northerly flow into the Midwest and the eastern United States. The temperature forecast trend does show a negative anomaly over the Midwest and the eastern United States. This anomaly is supported by the low-pressure area pattern, helping to sustain a northerly from Canada into the United States. Over Europe, we see above normal temperatures, associated with a warmer westerly flow from the Atlantic low-pressure anomaly zone. Going into late December and near the holiday, we are really pushing the whole forecasting system. But the first forecast trends do show a very similar pattern again, with a polar vortex core over Hudson Bay, and potentially a new cross-polar flow developing. We will keep an eye on these extended range developments. The temperature trends for late December do show a below normal signal over the Midwest and the eastern United States. But overall, the temperatures are harder to predict than the large-scale pressure anomalies. If the above pressure anomaly were true for late December, the resulting cold would be much more widespread than what the forecast below indicates. Every time we see a stable low-pressure anomaly over the Hudson Bay area, that has the potential for a cross-polar flow event over the central and eastern United States. Such a pattern over late December for the Christmas holidays would really create a magical atmosphere across a large part of the country.